Hello students, all of you welcome to the session. In this video I am going to discussing for GATE 2022 power electronics and power systems, what are the memory based questions we collected. For that memory based questions we are providing the detailed solutions. But in this video mainly I am covering the two subjects, power electronics and power systems. The next coming video will see the remaining subjects, that is electrical core subjects. Yes friends, first we'll start with the power electronics. We collected the data from the students. As for memory based, from power electronics, total, as for the data whatever we are collected, for that data only we are providing this information. The total 7 questions it is asked. Out of 7 questions, 2 marks questions are 4. 4 questions are 2 marks questions, and 1 mark questions are 3. This is the data given by the students who written GATE 2022. That is total weightage is, that is 4 into 2, that is 8 marks. 1 marks is 3 into 1, that is 3 marks. Total is 8 plus 3, 11 marks it is asked. Whatever the data we collected from the students, they given the data for 11 marks. It's a good weightage. And the difficulty level is, most of the students are feeling with respect to power electronics point of view, easy to moderate. Even the total GATE 2022 electrical paper also, that is also the average feedback is easy to moderate on. Even from the power electronics point of view, whatever the questions they solved, the students feedback is they given easy to moderate. Now we'll see the detailed solutions of the power electronics subject, whatever it is asked in GATE 2022. Yes friends, this is the question. This question is asked for, it is a 1 mark question. This is the 1 mark question. It's an easy question. This model is already framed in GATE. This is the previous model only. Direct this model, just some values are they change. It's very simple. Okay, this question is asked for 1 mark. This is the previous GATE model question. That's why mostly I'm suggesting the students, first you give the preference to whatever the previous GATE questions are there from 1991 to who are preparing for GATE 2023. You prepare from 1991 to 2022. That models first you complete. That is my suggestion. That's why this model, most of, not only this model, next 3 or 4 models of questions also, that is the previous GATE models one. Just some values they changed. Okay, that is my suggestion, friends. Now this question is selected from the rectifiers. That is the performance parameters of a rectifier. This question is performance parameters of a rectifier. Once you know the knowledge on the fundamental knowledge on the performance parameters of rectifiers, we can easily solve this question. What it is asked, friends? The input power factor is asked. Then what is the formula? You know from the concept of performance parameters, what is the input power factor? You please concentrate. Input power factor. Yes, friends, the input power factor equal to IS1 by IS into cos pi 1. This is the fundamental formula in rectifiers. Who are studied the rectifiers concepts. From the fundamentals, you know this formula, IS1 by IS into cos pi 1. What is the IS1 here? The fundamental source current. What is the IS here? The total source current or secondary current. If it is a transformer, that is the secondary current. Yeah, this is a fundamental source current. This is the total source current. Where pi 1, what is the pi 1 here? That is the displacement angle. That is the angle between Vs and IS1. Angle between Vs and IS1. Now, sir, how to identify which is the fundamental component? It's very simple. See, this model is asked, there is no any harmonics in the voltage waveform. Sometimes in future we may expect by giving the voltage also with harmonics, but that model is still not framed. But here this is the voltage is given, this is the current is given, but current is given with harmonics and voltage is without any harmonics. First identify the which is the fundamental component. Students, it's very simple. Just see the frequency component. Here omega is given, here also omega. That's why this is the fundamental component of source current. This is the fundamental component because this frequency and this frequency is equal. And this is the multiples of the frequency. That's why this is the third order harmonic frequency. This is the fifth order harmonic frequency. But I want which one? Only fundamental source current. What is IS1 notation, students? RMS value of fundamental source current. This is the 10 sine omega t means this 10 indicate the which one? Peak value of fundamental source current. But I want RMS value means 10 by root 2. 10 by root 2. Now I want what the total secondary current. The total secondary current IS equal to square root of. For this type of current relations, how to find the total RMS value that you know? That is, it is A1 sin omega t, A2 sin 2 omega, A2 sin 2 omega t, A3 sin 3 omega t, like this it is given. Then how to find the RMS value? A1 by root 2 whole square plus A2 by root 2 whole square. That formula, all of you well know that one. According to that, I am writing here. That is 10 by root 2 whole square. 10 by root 2 whole square. And this is the 4 by root 2 whole square. 4 by root 2 whole square. And this is the 3 by root 2 whole square. This is the total secondary current. Yeah, this is how much, students. You can do this calculation. Approximately, you can get 7.9. This 10 by root 2 value is 7.07. Yes. I know the IS1 value. I know the IS. IS1 is the RMS value of fundamental source current. IS is the RMS value of total source current or secondary current. Then what is the pi 1? Pi 1 is the angle between Vs and IS1. Here Vs is nothing but a V, source voltage. And this is the Vs and this is the IS1. Then what is the angle between these two, students? This is omega t. This is omega t minus pi by 3. Then what is the angle? 60 degrees. That is pi by 3. That is pi 1 equal to 60 degrees. That is pi by 3. That is equal to 60 degrees. Now you substitute all the values. What is the input power factor? The input power factor equal to. Yes, friends. What is IS1? The fundamental source current equal to 7.07. Then what is IS? This is 7.9 into cos of 60. You simplify this one, how much you can get? Yes, students, tell this one. What is the value of 7.07 by 7.9 into cos 60? This is approximately equal to 0.447. Always input power factor is lagging. Already it is given. This is the lag. 0.447. Yeah, this is the input power. It's a very simple question. It is a 1 mark question. Fraction of minute we can solve. But this model, once again I'm repeating, this model is the previous model only. This model already framed in GATE exam. Just by changing the values, that values are given. Same model is framed. Yes, friends, this is the one question. This total data is collected from the students who written the GATE 2022. This is the memory based. Yes, friends. Please concentrate. And this also, this question is asked for, this question is, I think it is given for 2 marks question. It is a 2 marks question. This is framed. Yes. I think it is not a 2 marks. It is given that it is a 1 mark question. It is also 1 mark question. Yes, friends. This also question selected from the rectifiers, but given circuit is which one? It is a semi-converter. This is a question on rectifiers. It is a semi-converter. It is asking that what is the amplitude of the fundamental component of the source current. I think all of you well know in the Fourier analysis of semi-converter. By using the Fourier analysis of semi-converter, what the peak value of source current? Amplitude in the sense peak value. The maximum value or peak value of fundamental source current. The fundamental source current, friend. The peak value of fundamental source current is 4I0 by pi 4 I naught by pi into cos alpha by 2. Cos alpha by 2. If it is a full wave rectifier, it is a single phase full wave rectifier, it's a directly 4 I naught by pi. If you want RMS value, is 2 root 2 by pi into I naught into cos alpha by 2. It is what is the RMS value of fundamental source current? The RMS value of fundamental source current is 2 root 2 by pi I naught into cos alpha by 2. Because it's a semi-converter. If it is a full wave rectifier, you don't get cos alpha by 2 times. It is multiplied with cos alpha by 2. Sir, how we are getting this formula? By applying the Fourier analysis only. We know that in a semi-converter, the source current is quasi square waveform. If you apply the Fourier analysis for quasi square waveform, then we are getting these formulas. But I'm not giving derivations all these. But already you know the concept. Then how we can apply that concept that I'm explaining here? That is 4 I naught by pi into cos alpha by 2. Then all the values it is given, students. 4 into what the current it is given? DC current. This DC current is nothing but this is the DC current. That is the load current only. That is how much it is given? 15 by pi. Alpha is also given. How much firing angle is given? The firing angle is 45 degrees. It is given, students. That is into cos 45 by 2. Then you simplify this one. What up? It is asked that it is not RMS value. It is amplitude. It is asked. Amplitude. Please concentrate. Amplitude. It is asked. Yes. If it is RMS value, if you apply this formula, then finally you can multiply with root 2. Then also we can get. But directly I applied here 4 I naught by pi into cos alpha by 2. Then by simplifying this approximately, we can get, students, do these calculations. To do these calculations, approximately we are getting this. I am giving this answer. I am giving, students. You please concentrate this. Approximately how much you can get. You do that calculations. 17.6 amperes. You get 17.6 amperes. This is the peak value of secondary current. Sorry, peak value of the secondary current or source current. Okay, this is the source current it is asked. What is the current? The fundamental value of the, that is the fundamental value of the source current. That is the peak current. It's not RMS current. Just by applying this formula. You can apply this formula, students. You can get the answer. 4 I naught by pi into cos alpha by. Sir, how we are getting this formula, sir? We know that in a semi-converter, the source current waveform is which waveform? It is a quasi square wave. The source current is which waveform, students? It is a quasi square waveform. By applying the Fourier analysis for this waveform, let this is the amplitude of source current is load current one, because in the source also which current is flowing? Load current is flowing. By applying the Fourier analysis for this waveform, then from that you can calculate the peak value of the secondary current or source current. Clear, students? The answer is 17.6 amperes. This is the 1 mark question. Yes, friends. I think it is not a 1 mark question. Please correct this one. It is a 2 marks question. It is a 2 marks question. Yeah. One more question, students. This question is also asked from the rectifiers, and this is the 1 mark question. It's very simple. A single phase full bridge diode rectifier. It is a diode rectifier circuit. A load is given 50 ohms. This model also already there in GATE exam. Single phase AC supply. If the diodes are ideal, then the active power in watts drawn by the load is how much active power supplied to the load. It's very simple. Given that it's a diode rectifier, students. Single phase full wave diode bridge rectifier. Okay, this is the diode rectifier. Let's concentrate, all of you. It's very simple models. That's why GATE 2020 is the average to moderate only. This is given for resistive load. Okay, this is the diode rectifier. Yes, friends, Vs equal to Vm sin omega t. Vm sin omega t. That this is the D1, this is the D3, and this is the D4, and this is the D2. This is how much it is given, students. Resistive load is 50 ohms. The supply voltage is 200 volts 50 H. The supply voltage, how much it is given? 200 volts, 50 Hz. This is a 200 volts, 50 Hz. If 200 volts, 50 Hz means this is the which value? RMS value. We know that in single phase, whatever the supply is given without any function, that is the RMS value. Then for resistive load, what is the output power? The power delivered to the load means it is active power. Then what is the power delivered to the load, students? Come on. The power delivered to the load P equal to, that is V naught RMS square by R. V naught RMS square by R. Then how to find the RMS for full wave diode bridge rectifier? What is the RMS value? Vm by root 2. We know that V naught RMS equal to Vm by root 2. What is Vm? It is given, but Vs is given. It is RMS value. Vm means root 2 into 200. Root 2 into 200 by root 2. Then root 2 cancel. Then how much RMS voltage? 200 volts. Once you know the RMS voltage, that is 200 square by how much resistance? 50. Then what is the load power? That is the output power. The output power equal to how many watts? It is 800 watts. It's very simple. Fraction of minute we can answer. How simple it is. See the students who are feeling GATE is very difficult. GATE is not difficult, but you know the concept. It's very easy. First, you want to build up the concept. But this model is also previous GATE model only. Yes, friends. And this question is also, this question is selected from the inverters. This is the 2 marks question. 2 marks question asked from the inverters. It's very simple. Yes, friends, consider an ideal full bridge single phase DC to AC inverter with a DC bus voltage magnitude of 1000 volts. The inverter output voltage V of T shown below. This is the inverter output voltage is obtained when diagonal switches of the inverter are switched with 50% duty cycle. It is a square 50% duty cycle means it is square wave generation. No doubt at all. It is a 50% duty cycle. It is a square wave generation. That is the meaning. Okay. The inverter feeds a load with a sinusoidal current. The inverter current is this is the current. Then you find the what is the power delivered to the load. It is also very simple. Yes, friends. Let's consider this is the inverter. Just a minute, all of you. Yes, see this one. It's very simple. Giving the solution. This is the inverter circuit. It is a full bridge inverter. It is a single phase full bridge inverter. A single phase full bridge inverter is how many switches? 4 switches. Actually, in the switching of inverter, only you can switch the diagonal switches only. You don't switch the, give the triggering to 2 switches in one leg at a time. That you know the concept. Always we can make the diagonal switching on. Diagonal switching. A diagonal switching in the sense, for example, this is the full bridge inverter. This is the full bridge inverter. There is some feedback diodes also. In full bridge inverter, there is a feedback diodes also. Diagonal switching means this is S1 and this is S2 and this is the S3 and this is the S4. That is the meaning of diagonal switching. Then this and this. Here load is connected. And there is some feedback diodes. I'm not drawing the total circuit, not required here. This is the inverter circuit. It is a single phase full bridge inverter. Full bridge inverter. The output is connected to the load. For this single phase full bridge inverter, output is connected to the load, students. All of you concentrate. Here it is connected with some load. And this is the output voltage of the inverter. What is the output voltage of the inverter? This is the output voltage of the inverter. Yes, the waveform is given. The output voltage of the inverter is given as a waveform. That is a square waveform. It's a 50% duty cycle. That is the square waveform. Now the output current of the square waveform is I. That is given. This is the output current of the inverter. Now you know the voltage and you know the current. Then you find the power delivered to the load. Power delivered to the load means active power delivered to the load. But it is not a pure sinusoidal, students. It is not a pure sinusoidal. Point to remember, our current is sinusoidal, but voltage is not sinusoidal. If voltage is not sinusoidal, it is a square waveform. It is a square waveform means it consists of fundamental and harmonics also. But which component is responsible to deliver the power to the load? Yes, only fundamental component is responsible. That's the reason why. But current does not have any harmonics. No problem. Current does not have any harmonics. But voltage is having square. Voltage is given that square waveform. Square waveform is it consists of fundamental plus harmonics. Then which component is responsible to deliver real power to the load? Only fundamental component. Now, if you apply the Fourier analysis for this waveform, then you know the concept. The fundamental RMS output voltage is fundamental voltage. The fundamental voltage of this waveform is 2 root 2 by pi into Vs. 2 root 2 by pi into Vs, where Vs is the supply voltage of the input. Now, this is the V01. V01 into I. What is I? In I also, I want to find the fundamental current. Fundamental current, it is a fundamental only because it is a sinusoidal. Sinusoidal is nothing but only fundamental current. It does not have any harmonics. Then, what is the RMS of that current? What is the RMS of that current, students? That is 10 by root 2. 10 by root 2. Then, what is the output power? Here, I want to find the output power. Output power is nothing but a V01 into I0 into cos pi. That is, pi is the angle between the voltage and the current. Then V01 is how much? Yes, come on. Just use substituents. Okay, V01 is 2 root 2 by pi into Vs is 1000 volts. That is the DC voltage. I0 is 10 by root 2. Yes, I will write in the next slide. It is better. Yes, concentrate. That is P0 equal to V0 equal to 2 root 2 by pi into Vs. Vs is how much, friends? It is 1000 volts. It is given. It is given that 1000 volts. I0 is, that is RMS current, 10 by root 2 into cos pi, where pi is the angle between voltage and current. What is the angle between voltage and current? The current is lags by angle of 30 degrees. Sorry, 60 degrees. Pi by 3, it is a 60 degrees. Cos 60. Then if you simplify this one, then how much output power you can get, students? You please do this calculation. Come on. Respond. How much output power you can get? The approximately 3183.09 watts you can get. This is the output power. That is 3183.09 watts. Clear, students? Yeah, this is very simple. Simple calculations. This output power you want to mix voltage. But here you want to get idea. We want to find the which one? Yes, RMS value of fundamental output. Because the fundamental component is responsible to deliver real power to the load. Then it is the RMS output current, because already output current is given. But I want RMS current. Then 10 by root 2. Then you do this calculation, students. We are getting finally 3183 watts. Approximately it is equal to 3183 watts. Yes. This is also very simple model. This model not framed still now in GATE exam. This model is not framed, but in analysis of choppers, and this question is based on the buck boost regulator. In the analysis of buck boost regulator, you know the direct formula. From that formula, you can easily solve these constraints. Here we want to find the value of the output capacitor in microfarad, and waveform is given. From this waveform, we can make the some data. Yes, friends. Here current is rising means this is on time. Here current is falling means this is the off time. Yes, friends. Now you tell me this time is given in microseconds. First, what is the given data, students? The ripple, peak to peak ripple voltage is given. Delta VC. Delta VC equal to 1 volt. Then what is the T on? T on equal to 20 microseconds. See the axis. This is the microsecond axis. T off time. Off time equal to 30 microseconds. Then what the total time period, students? The total time period equal to on time plus off time. This is equal to 50 microseconds. Now I want to calculate the duty cycle. What is the duty cycle? Duty cycle equal to on time by total time period. What is the on time? 20. The total time period is 50. That is 20 by 50. The duty cycle equal to 20 by 50. This is the duty cycle. Now, actually, what is the formula for delta VC, students? The peak to peak capacitor ripple voltage equal to, in the case of buck boost regulator, in buck boost regulator. Even for boost regulator also same formula. For boost regulator also same formula. For buck boost regulator, this is a d I naught by Fc. D I naught by Fc. Now from this you want to calculate the capacitance. If you want to calculate the capacitance means I know the duty cycle. I already calculated the duty cycle. But what the frequency? Frequency equal to 1 by 50 microseconds. 1 by t. 1 by t. That is 1 by 50 microseconds. Frequency equal to 1 by time period. 1 by 50 into 10 power minus 6. I know the frequency. I know the d value. But to calculate the C, because already delta VC given, that is peak to peak capacitor ripple voltage is given. Then to calculate the C, first I know the what is the I naught. Then how to calculate the I naught? To calculate the I naught, this waveform is given straight because this is the inductor current waveform. Then what is the average inductor current? In buck boost regulator, IL average is equal to, this is the formula, I naught by 1 minus T. Even for boost regulator also same formula. But for buck regulator, IL average is equal to I naught. IL average is equal to I naught. But for boost regulator and buck boost regulator, IL average is equal to I naught by 1 minus T. Then what is IL average? This IL average from the waveform. That is minima to maximum. Minimum current is 12 amperes, maximum current is 16 amperes. Then what is IL average? 12 plus 16 by 2. How much, students? It is equal to 14 amperes. This is equal to 14 amperes. Once you know the IL average, then 14 equal to I naught by 1 minus D is how much you calculated, students? D equal to 20 by 50. That you can substitute here, 20 by 50. Okay, this from this you can calculate I naught. Then how much I naught you can get? Come on, 14 into, that is 14 into 30 by 50. Yes, students, 30 by 50. Then you substitute all these values. Delta VC equal to 1. Then D equal to 20 by 50. Duty cycle equal to 20 by 50. I naught equal to 14 into 30 by 50. 14 into 30 by 50. Come on. This is 30 by 50 by the frequency equal to 1 by 50 microseconds into 10 to the power of minus 6 into capacitance. Then from this, what is the C value, students? Then you simplify this one, we can get C equal to 168 microfarad. We can. This is the calculation of C. This is also asked for 2 marks question. Just by remembering this formula, what the peak to peak capacitor ripple voltage in the case of buck boost regulator, in the analysis you know this formula. Just by remembering this formula and this formula, how to calculate IL average, then easy to answer this question. Then to calculate IL average, that waveform is given. To calculate that IL average, the waveform is given. Then how much we are getting, students? C value, the capacitance value equal to 168 microfarad. Sir, it is given that output capacity. You know that in buck boost regulator, if you draw the buck boost regulator circuit, this is the buck boost regulator. The capacitor is at load side only to reduce the ripple voltages. To reduce the ripples in the voltage. The capacitance is connected at the load side only. This is the load. Okay, this is the buck boost regulator. This capacitance value is asked. And this inductor average current you calculate. Okay, this is the switch. Yes, friends, this capacitance value is asked. How much we are getting? 168 microfarads. Yes, all of you got this answer? Is it correct? Yes. Yes, friends. One more question. This also 2 marks question in GATE exam, GATE 2022. Yes. Total 11 marks it is framed in. I think most of the questions are easy to moderate on. Yes. This is the question based on the 3-phase inverters, 3-phase inverter and sinusoidal PWM technique. Mostly in previous GATE exam, if you take the previous questions, a single phase full bridge inverter, sinusoidal PWM is repeated models. But this year it is given that 3-phase bridge inverter, 3-phase bridge inverter circuit, and it is a sinusoidal PWM. It is very simple. These are same formulas only. But here we want to write in terms of phase values and line values, voltage equations. Okay, that is very simple, students. Here it is given that it's an inverter. It's three-phase bridge inverter using the sinusoidal PWM technique. It's a three-phase bridge inverter. The output is connected to the grid. The output is connected to the grid. This is the grid. It is connected to the grid. The phase current is given that 10 amperes. The phase current is given that 10 amperes. Yes, friends. The power is given. The total complex power is given minus 4,000 minus J 3,000. Minus 4,000 minus. But here negative power is given means the power is delivered from the grid to inverter. That is grid to the inverter. That is the meaning. Yes. This Vs, how much it is given? Yes, 1000 volts it is given. The Vs equal to 1000 volts it is given. Now here it is asking that what is the modulation index? What is the modulation index? Using the sinusoidal PWM technique. Here which one? Sinusoidal PWM technique. Yes, friends, we know that in sinusoidal PWM technique, the RMS value of the voltage, the RMS value of the output voltage, fundamental output voltage equal to MVS by 2 root. This is the phase value. This is the phase voltage. MVS by 2 root 2. Yes, friends. Here from this we want to calculate the modulation index, where M is the modulation index. What is the M here? Modulation index. Here I written RMS value directly. Modulation index. You want to calculate modulation index. Now tell the students, if you want to know the modulation index, then I want to find the what is the voltage, phase voltage. Then to find the phase voltage, already the complex power is given. Apply the concept of active power equation or apparent power equation. And directly I'm applying the apparent power. The apparent power equal to 3 into V phase into I phase. 3 into V phase into I phase. What is the apparent power, students? Square root of 4,000 square plus 3,000 square. This is equal to 5,000. Is it okay? Now substitute the apparent power. This is equal to 5,000 volt amperes. 3 into V phase. Then I phase is how much? 10. Then how much phase voltage we can get? The phase voltage equal to 5,000 by 30. This is approximately equal to 166.6 volts you can get. Now you substitute phase voltage here. That is 166.6 is equal to phase voltage equal to, yes, come on students. This is M that you want to find. Vs is 1000 volts. M into 1000 by 2 root 2. Then from this, how much modulation index we can get? Okay, that you do the calculation. So approximately we can get the modulation index equal to how much we can get, students? Come on, do this one. It's also very simple mode. This approximately modulation index equal to 0.47 we can get. Okay, this is the answer. Clear, friends? Just you know the formula from the sinusoidal PWM technique. The RMS value of output voltage MVS by 2 root 2. Then this is the phase value, but because it is defined for single phase, it is a phase value. Then from this given data, I calculated the phase voltage. Already phase current is also given. Phase current is also given. That I substituted here. I'm getting the modulation index equal to 0.47. Clear, friends? Understand? It's very simple model. See, every question we are solving the fraction of minute. Even 2 marks questions also we are solving the fraction of minute. Because I'm explaining, that's why it is taking more time. But you can do this one, fraction of minute you can. This is also question asked in power electronics, GATE 2022. It's 1 mark question. A charger supplies 1000 watts at 20 volts for charging the battery of a laptop. The power device is used in the converter inside the charger operate at a switching frequency 200 kilohertz. Which power device is best suited for this purpose? Very simple. Students, for low voltage, high frequency, for low voltage, high frequency, for low power and high frequency applications, which is the more suitable in SMPS applications? I think all of you well know this one. This question also repeated in all the compute exams. This model is repeated in all the compute exams. Then which is preferable? MOSFET is more. For high frequency, low power application. For high power and low frequency application at 50 Hz frequency, thyristor is preferable. Thyristor is preferable. But high frequency, low power application, the more preferable is MOSFET. For SMPS application, this is a repeated question in all the, even in ESC exam and other PSUs also, which is more preferable for PSUs, that is SMPS applications, switch mode power supplies application, MOSFET is more preferable. Okay, these are the questions framed in power electronics. Total, I discussed, this is 1 mark question 1, this is the 2 marks question, and this also 2 marks question, this also 2 marks question, and this is the 1 mark question, this is the 2 marks question, and this is the 1 mark. Total 4 2 marks questions, 3 1 marks questions, total 11 marks it is asked students. I think just by seeing these solutions, you got idea how simple it is, how simple it is. We don't know about the concept. Every student, no doubt at all. Even simple questions also you can feel it is a difficult. But you well known about the concepts, then it's a very simple. It's very simple. Most of the models are the previous gate models only. Previous gate models only. The next subject in this video I'm going to discuss power systems. As for the data collected from the students, the weightage is given that 8 marks. Maybe some questions are missing. That's why total we are not got the data. But as for data collected in power systems, it is given that 8 marks. In the total 8 marks, total the 2 marks questions are for 2 marks questions. 2 questions are asked for 2 marks questions, and 4 questions for 1 mark. 4 questions it is framed. 4 questions. This is 2 into 2, that is 4 marks, and this is 4 into 1, this is 4 marks. The total, as for the data collected from the students, it is also memory based only. Total 8 marks weighted it is given students. Maybe 1 or 2 questions it may be missing, but we don't know about that questions. Once you know the total question paper is out, then only you know the total, what is the total weightage. But for power system, up to whatever the data we collected, that is asked for 8 marks. Now see the students, this is the first question I'm discussing the in power systems. This is the question based on the sequence impedances. The valued positive, negative, and zero sequence impedance in per unit for 220 kV fully transport three-phase transmission line. That means, which is the correct option for the valid positive, negative, and zero sequence? I think all of you well know this one. For transmission lines, students, for transmission lines, the positive sequence is equal to the positive sequence reactance equal to, you can write impedances, or you can also write if you want to write impedances, or you can also write the reactance. The positive sequence reactance x1 equal to xs minus xm, where xs is the self reactance, xm is the mutual reactance. Then x2 equal to the negative sequence reactance, xs minus xm. Then the zero sequence reactance, x0 equal to xs plus 2xm. Here by neglecting here I'm not considering the neutral impedance or neutral reactance. Without considering the neutral impedance or neutral reactance, that I'm writing here, x1, x2, and x0. That means what is the observation here, friends? x1 equal to x2. That is the positive sequence reactance equal to negative sequence reactance, and the zero sequence reactance is very much greater than as compared to positive sequence reactance and zero sequence reactance. Sorry, as compared to positive sequence reactance and negative sequence reactance. Now, these conditions in the given options, this condition is satisfied by which option? X1 equal to x2. Positive sequence reactance equal to negative sequence reactance, and the positive sequence reactance, the zero sequence reactance is greater than the positive and negative. That is satisfied by the option C. 0.15, 0.15 and 0.35. This is the positive sequence reactance. Yes, friends. And this is the negative sequence reactance and it is the zero sequence reactance. The positive sequence reactance and negative sequence reactance are equal and these two are greater as compared to zero sequence, as compared to these two reactances, zero sequence reactance is greater. That's why which option is satisfied? Option C is satisfied. It's very simple question. Next. The most commonly used relay for the protection of an alternative against the loss of excitation. It's a repeated question in all the competitive exams. This question is repeated in all the competitive exams. Which relay is used for protection against the loss of excitation? For protection against the loss of excitation, offset mode relay is used. For protection against loss of excitation, which relay is preferable, students? We can use the offset mode relay. We know that Buchholz relay is used for transformer protection. Even differential relay is also used for transformer generator protection. Even overcurrent relays mainly used for the overcurrent relays we are using in the feeder protection. Okay. But mainly for against the loss of excitation, which relay you can use, friends? Offset mode relay you can use. It is also very simple question. This is also 1 mark question. All these are the 1 mark questions. Okay, this is the 1 mark question. And this is also 1 mark question. And this is also 1 mark question. Here it is asking that this option is different. Please correct this. It is 1.723 hour. Okay, just print mistake. It is 1. Here we want to find the what is the GMR of conductor. If the each conductor is having the GMR of this configuration, if the each conductor is having the radius of R, it is a standard conductor. It's very simple. Yeah, this is given that it is R squares. That means this is R. And what is this radius is also? Each conductor radius is R. Let this is the 1, this is 2, and this is 3, and this is 4. And this is R. And this total is how much, friends? Then what is the total this radius? This is equal to 2R. Okay, 2R. Then this is also R. And this is also R because the radius is R. Okay, and this is also R. Radius is R. Okay, it is a R, this is the R. Total equal to 2R. This total is 2R. Is it correct? It is a total 2R. And this is also R. Then what is this total? This total is 2R. Now you want to find the what is the GMR of the conductor? The GMR equal to that I am calculating. Yes, friends. The resultant GMR equal to the GMR of the conductor equal to, yes, friends. It's very simple. D11, you know this formula. D11 self distance, D12, D13, D14. It is a standard conductor. What is the D11? D11 is 0.7788 into R. What is the D12? D12 is 2R. But total is how many distances here? 4 distances. 4 to the power of 1 by 4. 2R. D13. Yes, friends. This 1, 2, 3, 4. D13 is also is 2R. What is the D14? D14. I want this distance. It's very simple. I want this distance. Yes, friends. D14 means this is the 2R and this is also 2R. And I want this distance. This is 1 and this is the 4. D14. What is the D14, friends? Square root of 2R square plus 2R square. 2R whole square plus 2R whole square. Okay, this is 2R whole square plus 2R whole square. Then how much you can get? 2 root 2R. This I am writing 2 root 2R. 2 root 2 r whole to the power of 1 by 4. Is it clear? Then you simplify this one. What the GMR you can get, students? The GMR equal to 1.723R you can get. This is the value of GMR. Clear, all of you? Then which option is correct? Option D is correct. It's very simple. 1.723R. A fraction of minute we can answer. As actually no need to solve this one. Already you know this result. Okay, it is a standard result for this one. 1.722R. You can directly do. Yes, friends. This also one more question. It is also very simple question. If only 5% of the supplied power to a cable reaches the output terminal, the power loss in the cable is decibel. Students, only 5% is reached to the output. If only 5% is reached to the output means, then how much percentage is the loss? The output is 5% means the output is 5%. Then how much loss, students? Loss equal to how much? It's a 95%. 95% means 0.95. That means you want to find this power loss in dB. It is a power calculation. It is a power calculation means 10 log. It is voltage or current calculation means you take the 20. But it is a power calculation. Power loss equal to 10 log. That is 0.95. 0.95. This is how much you can get, students. Minus 0.22. This you do the calculation. How much we are getting? You please do this calculation, students. This is 223 dB. Is it correct? Yeah, this is the power loss. Once again, I'm doing the calculation. It's just a minute. Please do this calculation. This is log of 0.95. .95. Just a minute. Minus 0.022 into 10, that is minus 0.223 D. Okay, this is the power loss. Is it correct? Yes. The power loss equal to 0.223. See how simple it is, students. How simple. Okay, you who are feeling gate is very difficult. It's very simple, but some common sense is required. Yes, friends. Mostly, if it is asking in dB means suddenly we can get idea 20 lakh, but it is not a 20 lakh, it is a 10 lakh because the power calculation. Next, one more question. This is the 2 marks question. It's also very simple, students. It's very simple. Here we want to find the P1 and P2 for plant incremental cost. If the incremental cost is given 8 rupees per megawatt hour, but here options also given in the question, but that options I'm not providing here. But for this question, options also there. For this question, options also there. But here I'm not providing that. Yes, friends. It's very simple. This fuel cost of the 2 plants are given, and demand is given. Even incremental cost is also given. Then you find the what is the P1, P2 for incremental for economic load dispatch. This is the question selected from the economic load dispatch. Then you find the what is the P1 and P2. You want to find the what is the P1 and P2 spreads. It's very simple. Then what is the fuel cost of the plant 1? F1 equal to 0.004 P1 square plus 6 P1 plus 350. That is in rupees per hour. Fuel cost is in rupees per hour. Yes. 0.004 P1 square plus 6 P1 plus 350. Then, but I want to find the for economic load dispatch. What are the conditions, students? For economic load dispatch or to reduce the fuel cost. For economic load dispatch, or to reduce the fuel cost, what are the condition? Incremental costs are equal to the, that is IC1, IC2 and so on, ICN. If there is n plants, here 2 plants, IC1 equal to IC2 equal to lambda. That is the IC1, IC2, that is equal to lambda. That is the Lagrangian multiplier. That is the lambda. Lambda value is given 8 rupees per megawatt hour. It is given. Then incremental cost. What is IC1, students? IC1 equal to dF1 by dP1. This is the fuel cost and this is the incremental fuel cost. Then what you can get? 0.008 P1 plus 6. Then what is the F2 it is given? F2 equal to 0.003 P2 square plus AP2, yes friends, plus 450. Then what is the dF2 by, actually dF2 by dP2, dF2 by dP2, that is 0.006 P2 plus A. Yeah, this is the IC2. And here demand is also given, students. The total demand P1 plus P2 equal to how much it is given? 250 megawatts. P1 plus P2 equal to 250 megawatts. Now see, IC1 equal to IC2 equal to lambda. See, just we can equate IC1 equal to lambda, students. Then you can get the P1 value. IC1 equal to lambda you can equate. What is IC1? 0.008 P1 plus 6 equal to lambda is 8. Then what is the P1 from this one? Come on, do this. What are the P1, students? This P1 equal to, that is 8 minus 6, 2 by 0.008. Okay, this is how much you can get, students. Approximately that is how much we are getting. Come on, do that. 250 megawatts we can. P1 we are getting the 250 megawatts. Once you know the P1, if P1 equal to 250 megawatts, then what the total demand it is given? We know that P1 plus P2 equal to 500 megawatts. Then what the P2? P2 equal to 500. It is a 500 or 550. What the total demand it is given? It is a 550. It is correct. It is given that 550. Then you substitute here, friends. Come on. Yeah, this is P2 equal to 550. P1 plus P2 equal to 550. P1 plus P2 equal to 550. Then P2 is 550 minus P1. P1 is 250. This is equal to 300 megawatts. Actually, in the exam, options also given, but here that is not typed in that question. The options are missing here, but actually in the exam, options are given. Then P1 equal to 250 megawatts. Then P2 equal to 300 megawatts. Then whatever the option is there, like this, that option you can select. P1 equal to 250 megawatts and P2 equal to 300 megawatts. It's a 2 marks question. And this question also you can solve in fraction of it. Clear, friends? Yeah, this also 2 marks question. But one more question is also there. But that question, exact question formation is not known. But the data is collected from the students. The data is collected from the students. Yeah, this is also 2 marks question, friends. Yeah, that question also I'm solving here. Yes. Yeah, it is given that this also 2 marks question. A 20 MVA, 11.2 kV. This data is collected from the students. 20 MVA, 11.2 kV. The number of poles equal to 4. The frequency equal to 50 Hz. Frequency equal to 50 Hz. And the inertia constant H is given 15 megajoules per MV. 15 megajoules per MV. Yes, friends. Then the input PS equal to 15 megawatts, mechanical input 15 megawatts. The electrical output P equal to 10 megawatts. This is a question asked based on the, yes, friends, swing equation. This is a question based on the swing equation. Then here we want to find the what is the acceleration in mechanical degree per second square. In mechanical degree per second square, it is free. It is asking that you want to find the what is the alpha, acceleration alpha in mechanical degree per second square. Okay, this is, then what the solution for this question, friends? It's very simple. Then you know the swing equation. M into d square delta by dt square equal to PS minus P. That is accelerating power PA, PS minus P, according to swing equation. That is M into alpha. That is M into alpha equal to PA. What is PS, students? That PS equal to mechanical input 15 megawatts, electrical output equal 10 megawatts. That is the 5 megawatts. Then what is alpha equal to? This is 5 by M. But what is M, students? M equal to, because it is given that you know the M formula, moment of inertia, that is M equal to GH by 180 into F. This is in electrical degree per second square. Electrical degree per second square. This is the formula. Yes, sir. GH by 180F, GH by 180F. That equal to 5 by how much G? What is the rating? It is given 20 MVA. Inertia constant is how much? 50 by 180 into frequency is how much? 50 Hz. Okay, this how much you can get. Please do this one. 150 electrical degree per second square you can get. By simplifying this one, 150 electrical degree per second square you can get squares. Okay, this is the alpha. But here you want to find the mechanical degree per second square. If you want to find the mechanical degree per second square. Then to find in mechanical degree per second square, to find, you know this one, to find in mechanical degree per second square. Degree per second square, students. Then how to find in mechanical degree per second square? To find in mechanical degree per second square, we know that theta E equal to 2 by, this is 2 by P into theta M. You want to find what is theta M. This is theta M equal to 2 by pi into theta E. This you know the relation. How to convert mechanical to degree. Mechanical degree to electrical degree. Now apply that one. Then to find in mechanical degree per second square, 2 by how many number of poles, students? How many number of poles? It is a 4 pole. That is 2 by 4 into what is in electrical, that is 150. Okay, this is how much we can get. 75 mechanical degree per second square. Therefore, what is alpha equal to? Alpha equal to 75 mechanical degree per second square. Okay, that is the answer. Okay, this is the data collected from the students, but total question formation, that is not collected. They given the data, then according to this data, and this is the answer, students. 75 mechanical degree per second square. Okay, that you concentrate. Total how many questions in power system that I covered? This is 1 mark question. 1, 2, 3, 4. 4 1 mark questions. 2 2 marks questions. 2 2 marks questions. This is total 8 marks weightage. This total 8 marks weightage. Yes, friends. Yeah, this is about the today's session. Okay, thank you. In the next coming session, remaining mainly 4 subjects: electrical missions, measurements, and network theory. I will give the in one more session. Okay, please concentrate. Okay, whatever, by seeing the questions, you got idea. Yes, whatever you studied, that models only it is framed. But at that time, during writing the exam, suddenly you are not got the idea. Sir, how we want to get that idea? If you practice more and more, then compulsory every student can get the idea how to solve the any questions. Okay, thank you, students. Yeah, this is about the session.